All right, so we did a problem like this yesterday that was much more involved. Okay, this one, if you don't know where to start, there's a few different places that one could look to. Let's check this out. I need a coordinate plane. Can you guys tell me any x's that are going to be important based on anything written up here? -2 is an important one. 3 is an important one. Those are the only ones that show up, right? So if we're not sure what to do, that's okay. If we make a mistake, it's not the end of the world, right? Like, mistakes happen. If we have to ultimately cross this out and do another graph because it's easier than erasing, that's okay. Now, I'm just going to mark off 2, -2, and 3, right? So I don't know why it's so hard for me to see. -2 and 3. Now, for this, I'm going to run through all the options. If I look at, and these aren't really A, B, and C, this is just so we can talk about it. Which one, Lily, we made eye contact for a moment. Which one of these is your natural start, A or B or C? A is a reasonable natural start. Now, it's not where you initially began. Okay, just to look at this. If we had began, and I would start here as well, just so you know. But if we had began at C instead, which is, I think, what somebody might have started with first, I know two things. It either goes up like this forever, or it does what? It either does that or it goes down forever. And I don't know which one it's going to be. Because I don't have a way to lock that in, I probably wouldn't commit to this right from the get-go. Okay, if we do A instead, what does it mean to be greater than or equal to 0? So it can either be here, and I'm going to just put it here because that's allowed. It could be greater than or equal to 0. Is this true? Now, why did I actually include this point? What up here tells me that I should include it? The brackets. That's a closed interval is what we say. Okay, so I know from here it's greater than 0 means above the axis, right? Now, I don't know exactly what it does. It might do something boring like a regular parabola. That was kind of what I was thinking about while I was making this. But could it do something wonky like this too? Like, if I do something crazy like this, does it still satisfy all this condition? Now, it's not natural to do a wonky one, right? Like, more naturally, I think one would probably do something like this. Okay, so that part's knocked out. I think I'm close to eliminating one of these two pairs. Whoever's phone, if you'll just make sure it's on silent, if that was a phone. I don't know who it was. Lily or Hawaii is my guess. Okay, let's look at B then. Less than 0. It means that after I pass this, between -2 and infinity, should I be below the axis or above it? Below. Have I now locked in the rest of my problem? The second I draw below, here it is, and it might join up and maybe it has a little hiccup. I know for sure that this one's gone. Do I get the other one to disappear as well? Why? It's even. It's going to match either way. Okay, once it's there, boom. Here's the most boring graph. Now, boring not in a bad way, just so you know. Based on these conditions that we've given, it could be a bunch of graphs, literally infinitely many. Okay, Liam. Okay, does this graph also satisfy this? It's a weird one, like it has some sharp turns, which is strange to see. But yeah, this is still satisfied. You could make it a boring parabola, not that that's necessarily super boring. It could do all sorts of crazy stuff here. Maybe it does something like this. Does this still satisfy all the given information? As long as you are above in this section and below in these sections, I don't care what else is going on. Cool. Okay, we have one last little comment to make in our notes. Yesterday, I believe we left off doing similar types of problems. Now, how many of you, if you had to right now, could make a table on your calculator? Okay, if you struggle with it, it's okay. Remember, I'm here to help. Sweet. Okay, we have like 2 comments, is it? Just 2 really, or 1 realistically, really quick and easy comment to make. Now, if you guys still have this example, do you have a graph that bends and curves like this as well? Okay, couple things. Yesterday in class, when we had our graph, and I'm going to redraw it just more accentuated, you can do it. I lied. I'll do it on this graph. I assume all of our graphs look pretty much the same. Okay, on this graph, here's my big question for you. we went through the stuff yesterday. That's a degree 3, and obviously degree 3 because I can see it here. But how do I know it's degree 3 just looking at this? So the cubic term, what if I only look at the graph? Do I still think it's a cubic? How many turning points does it have? It has 2. Now, coincidentally, these turning points, you might call them something else, I think. Instead of a turning point, which it certainly is right here, is this bigger than all of its neighbors? And what I mean by that is if we zoom in on this, and I'm just going to draw a slightly different graph just so you're aware. Last little thing, you can add it on your graph if it's really accentuated, or we can just sketch one more little easy graph. Let's say that I have something much more obnoxiously curved, something like this. Okay, this function right here, f of x, does it have turning points? How many? 2. So it has 2 turning points, which makes me think it's probably which degree? Is there any additional evidence to convince me that it's a 3rd degree? The arrows, so it's odd for sure, but it could be 5th or 7th as well. Why 3? Somebody said it. There's 3 x-intercepts. There's 2 turning points, which is 1 less, and there's 3 zeros. 1 or x-intercepts, roots, solutions, whatever you want to call them, all 3 of them. Now, when we have this, you guys, I assume, clearly see that that's a turning point and that's a turning point. In contrast, or additionally, is this bigger than all of its neighbors? So what might we call it? It is a turning point, you're absolutely right, but is there another word that we've used? This is an extrema. Which type of extrema is this? This is a maximum. Now we're going to clean up our language. When we're looking at extrema, love it. Maxima, love it. Is this the biggest the function ever gets, or is it only the biggest in this little relative region? Okay, so for this, we could call this a max, but there's 2 alternatives that are much more specific and helpful to us. Nope, we are back in our notes. Sorry about that if that wasn't clear. I thought I was looking at that one and then I just changed. My bad, Sonny, thank you. This is a relative, or the other word that I prefer is a local max. Now, maximum is the true word, but this is bigger than everything else. If I look at some little neighborhood, and that's the real word that gets used, some neighborhood around this, there's not a point that gets bigger y value. That's a maximum. Now, it's only relative compared to its neighbors, or local compared to its neighbors. Over here, we have a relative what? I'm going to point at the actual point. A minimum. Now, do you guys prefer relative or local? Because we're just going to decide right here, right now, and I'll try to use that word all the time. Okay. Not what I would pick, but that's okay. Now, realistically, I have no strong preference other than I'm kind of lazy, and which word has less letters? Like, legitimately, that's why I would pick that. Does this one have a biggest value or a smallest value anywhere on the whole graph? Does it, like, if I say, check it out, this is the biggest value that I see on my graph. That's true, but is it really the biggest value that's on the graph? No. Is it ever going to get to the biggest value? No, it's going to keep getting bigger and bigger forever, which means there is no absolute or global maximum. And we're just going to make that comment. I don't have a function that has that. We're going to say no absolute, and we're just sneaking in a vocab here. Bless you. Absolute, or the other word that might show up is the global. Now, there's no global maximum. There's also no global minimum. So instead of saying maximum or minimum, Sonny, what was that word you used earlier? Extrema. And I am 100% sincere. I don't know for sure if it's extrema or extrema. Extrema feels more natural word, but I don't know. Okay, could you draw me a really quick sketch, a graph that has the following? Last little thing, it'll take 2 seconds. You don't even have to jot down the problem. I just want to see it in your margins. I want to see 3 roots. And then I want, I actually want to change that to 4. Sorry. My bad. Because otherwise we're just going to get the exact same sort of graph. I want 4 roots. I want a local max somewhere. I don't care where it is. Sorry, you guys said relative. I want 4 roots, a relative maximum. Don't care where it is. And a global minimum. All right. That's it. That's all the information I'm giving you. There might be more than this, and that's okay. But I want something that has at least these three guaranteed. Really quick and easy sketch. We're going to have a million different graphs. Not literally. There's only like 15 of us. But this one? So is this the smallest y value ever to exist on this graph? So this is a relative min, but it's not a global min or an absolute min. So something has to change. I would make sure that there's a smallest value on your function. So the only way to figure out if there's issues is just to try it. If you're wrong, it's nothing in the world. Just sketch a graph that tries to do these things. What's this? So these were different characteristics from yesterday. And like, I appreciate that you're looking at the example here. Let me pause this because I don't need to record. Just think time. Which of these is the most natural starting point? I think for me personally, it's a global minimum, but it doesn't have to be. Now, if you are struggling with this, I would encourage pick something that you guarantee is like immediately going to be true. We could pick our 4 roots first. I'm fine with that. We could pick the minimum first. I'm cool with that. This is my natural starting point. Do you want me to start here or do you want me to start with roots? The minimum. Okay, so check it out. I know it has to eventually cross the x-axis, so I'm just arbitrarily picking something small. My function, again, no thought going into this other than it's a minimum. I'm going to make this point my global min. Global min, which means, is my function ever going to get smaller than this? No, which, can I go downward from here then? We just said it's never going to get smaller. We have to go upward. Now, it might go upward like this, and again, it could do other stuff, but this already satisfies it. If I want this to be a global min, I can keep working up. Now it's a global minimum. I can see that. What else do I need? We have a minimum as long as I don't dip underneath of it. A relative maximum. Cool. So right now I don't have one. How many roots? And I'm going to think about both of them simultaneously, which is a weird idea. I need a relative max, and I need 4 roots. How many roots do we have on our graph right now? 1. So I need a way to have a relative max, something like this, and you don't have to draw it right there, but I also need how many more x-intercepts? 3. Now I think, and this is just me thinking, if I keep coming up, could it possible that there's a root there? And another one here. And another one here. Now I have all 4 of them. I simply need to get a relative max somewhere in here. If I just connect these points, I think it's natural to come up to here. I should probably cross, right? Like that makes sense that it would cross. Okay, I'm going to cross, and then what am I going to have to do to get to this root? I have to go back downward. When I do that, I'm going to try to do that a little bit nicer. What did we just happen to make by coincidence? This is a relative max. Okay, now we are also going to get one more relative extrema out of this. If it doesn't break the rules, I'm cool with it. We can have more than is stated, we just can't have less. What's the only option for this thing? Can it go down forever? What must it do? It has to go back up. Otherwise, we wouldn't have had our global min. This graph satisfies all 3 of those criteria. It is not the only graph that works, but it does. Now, worth mentioning, we obviously have a relative max. We hit all these things well here. Is this smaller than all of its neighbors as well? Is there a neighborhood around it? And I'm just doing like some interval around it is all I'm drawing. Is this smaller than all of its neighbors? So it is the overall smallest, the global or the absolute minimum. Is it also a local minimum? If it's smaller than all of its neighbors, definitely. It's still smaller than everything relative to it. We have a relative min right here. Piece of cake. They take practice. It's weird because there's so many different variations. Anybody have a different graph that you'd like to check and you're happy or willing to show up on the board? All right. Cool. Seems hit it. So the global max will always be the biggest out of anywhere. So like if this function, is it ever going to stop getting bigger? No global max then. If we wanted a function with a global max, really easy to do, parabolas always. This is the biggest y value it ever gets to, but it could be anything, right? It could be something like this. Now this is a global and a local maximum. Cool. All right, you guys get a ton of time today, 30 minutes. Hopefully you don't have to take any homework home with you. We spoke for a couple more minutes longer than I was intending to, so thank you for your patience. Let's get our assignment. So tonight, check it out. I want you guys, for the next half hour, to begin working on 3.1. Your book said this was supposed to be a one-day lesson. I don't think we could have hit it all in one day. Maybe. I don't know. I don't feel very confident with it. Anywho, 3.1, page 124. You guys are going to knock out 5 through 14, 19 through 25 odd, 26, and then there's stars around 28. Try it. Try to do 28. If you do it, and you do it well, and you can explain it, I'll hook you up with pizza candy. Cool. Indeed. Sweet. You guys get a ton of time to work on stuff.